All right, so one thing I forgot to mention at the end of that last video is this idea of a horizontal asymptote. So we saw with the function e to the x, as x approached negative infinity, right? I can write that down. We had the limit as x approaches minus infinity of e to the x. We got 0, all right? So we got a finite limit as x approaches negative infinity. And so when that happens, we call that that line y equals, in this case, y equals 0. So y equals 0 is a horizontal asymptote. So I'll say, let's see, this is I'll just write it out. So horizontal asymptote. All right. So in example 2, we're going to graph e to the x. So I've got a table of values here, and I can plug in numbers, plug in these numbers for x, and I can calculate e to the x. Okay, so I'm just going to do that right now. All right, so I've used my calculator and calculated these values, these powers of e, as in decimal form, because it's easier to graph it if I have a decimal. And then I've plotted those points over here, at least the ones that are on the graph, at least as far as close as I can get. Now, it starts getting pretty small and it's hard to graph 0.0498. But you can see it just, the e values, or the values of e to the x are just getting closer and closer to 0. Okay, so this is what the graph of e to the x looks like. All right. Now, on the same graph, we want to look at the natural log of x. Now, remember that the natural log is the inverse of e to the x, right? So, I'm going to take, knowing that, I'm going to take a little bit of a shortcut when I calculate these values, because if e to the minus 3 is 0.048, 98 is e to the third, right? So, or e to the negative third, right? Then essentially, with an inverse, we're just swapping the input and the output. So what I'm going to do is I'm going to make these outputs -3, -2, -1, 0, 1, 2, and 3. Let me see if I just scroll up just a hair more. Okay, that's good enough, I guess. 3, right? And then these values over here are going to be e to the minus 3, e to the minus 2, e to the minus 1, e to the 0, right? Because the natural log of e to the minus 3 is minus 3. So I'm just going to swap the input and the output. That'll save me some time, maybe, right? I'll just calculate these values. Well, I can just copy these values down from the table above. So I'm going to do that now. All right, so there I have calculated these values, or copied these values down from the table above, just swapping the input and the output, and then I graph the natural log of x. So this is y equals ln of x, and this is y equals e to the x. Okay, so there's my graph of ln of x. All right, so you can see the horizontal asymptote, right? As x approaches negative infinity of e to the x, right, it goes to 0. Now, notice that the natural log has a vertical asymptote, right? So let's take a look at these questions down below. What is the value of ln of x for x less than or equal to 0? All right. So the question is, can we put in something less than or equal to x into the natural log of x? No, we can't, right? Those values don't exist, right? There's no power of e that would give us 0 or a negative number, and since the natural log is just the inverse of e, then we can't put any negative numbers into the ln of x. Okay, so those values don't exist. Now let's investigate the limit as x approaches 0 from the right of the natural log. Okay, so I'm just going to use my calculator and put in some values of x and calculate. Okay, now I know you can try it yourself. Put in 0, it's going to give you an error. So this does not exist. All right, but okay, so let's do it right. Let's approach 0 from the right. Let's start over here. On the right hand side of the table, if I put in 0.01, I get a negative for 0.61. If I put in 0.001, I get a negative 6.91, and this gives me a negative 9.21. Okay, so I'm getting more and more negative as I approach 0 from the right. Now, those don't look very big. They aren't very big negative numbers. But if I put in something like ln of e to the let's say 0.0000001, whatever that is, I could calculate that as a number. If I put that number in, what I'm going to get is 0.0000001. Okay, so I could choose the value of x as big as as small as I want, and I'm just going to get smaller and smaller numbers. Okay, so we can say that the limit as x approaches 0 from the right is it goes to 0, but it doesn't, or sorry, it goes to, what am I saying? It goes to negative infinity. So I'll just write that here, negative infinity. It goes to negative infinity. All right, it just gets more and more negative. All right, now let's go the other way. If we look at what happens to ln of x as x approaches infinity. All right, so we're getting bigger and bigger. Let's start with ln of 100. Okay, so I'm going to get 4.61, and ln of 1,000 gives me 6.91. Right, that's saying e to the 6.91 is 1,000. And this is going to be 9.21. I put it in my calculator, and this gives me 11.51. Okay, that's saying that e to the 11.51 is 100,000. Okay, now it's getting bigger and bigger. Right now, it's not getting bigger and bigger very fast, but it is getting bigger and bigger. So again, like if I looked at the natural log of e to the, let's say, 1 million. All right, this is e to the 1 million, right? That's a huge number. I probably wouldn't even be able to write it. If I put it in my calculator, e to the 1 million, it would probably not, it probably would give me an error because it's just so big, right? But we know that that has to be 1 million, right? Because that's the way the natural log works. Okay? So the natural log gives you the exponent on e, right? And so what are the domain and range of the natural log of x? All right, so domain. Let's look at the domain first. So what did we find out about the domain? That's the set of all the possible input values, the x values. If we're looking at natural log of x, what are the x values that are off limits? Well, we already saw it can't be less than or equal to 0, right? So it can't be equal to 0. It can get as close to 0 as you want. It just can't go to 0. So it's 0 to infinity, right? We can put in numbers as big as we want in, and we can calculate a value. But we can't put anything 0 or negative. Okay, so that would be our domain. And let's look at the range. The range, those are the output values, right? The y values. So it looks like we can choose values to get any negative value we want or positive value we want. Okay, so the range of the natural log is minus infinity to infinity. Okay, all right, so I'll see you in the next video.